I'm Phillip Williams, and I'm a research physicist within the non-destructive evaluation sciences branch within the research directorate here at NASA Langley. I got involved in with NASA actually through a NASA educational program, specifically the National Research Council Postdoctoral Associate Program at Langley. While I was nearing the completion of my graduate studies for a doctorate in physics, I started to think about what were the next steps in terms of further education or employment outside. And while I was in graduate school, I worked on a project, as part of a team actually, worked on a project that developed a tool that actually allowed you to manipulate objects on a really, really small scale called the nanomanipulator. And one day I was in a meeting where it was discussed that that project was actually patented, licensed, and then made commercially available by a spin-off company. And during that meeting, I also found that NASA Langley was the first commercial customer of the nanomanipulator, and they were using it to study carbon nanotubes, which was the same material that I had used the nanomanipulator to study. So I thought, wow, great match. Came down to NASA Langley Research Center, visited with the researchers using the tool, as well as the Office of Education, and found out about a program, a postdoctoral program, that allowed me to come on center, and that began my path. After being a postdoc, I spent some time as a contract research scientist, and then finally a civil servant research physicist. While here at NASA, I've worked with several projects in aeronautics as well as the space side. Specifically, since my background was in nanomaterials, I've looked at nanomaterials for sensors, for aviation safety, and also for exploration. Nanomaterials encompass studying materials that are about 10,000 times smaller than the diameter of a human hair, but possess remarkable mechanical and electromagnetic properties, such as being about 100 times stronger than steel, but yet 1/6 the weight. And so we can use these materials to advance next generation vehicles, sensors in a host of applications. Another project I've worked on briefly was using lasers as a spectroscopy technique for studying the orbiter pressure vessels that are used to hold pressurized gases. And also I spent some time doing some computer modeling and simulation of interactions of energies with flaws and defects in structures to help inform physical inspections and save on cost and time. The most exciting aspects of my job, actually I would say, include wide ranges of projects, of people, and possibilities. From a project standpoint, only at NASA Langley are you able to study something ranging from the very small, too small to actually be seen unaided with the naked eye, to also things such as celestial bodies that are much larger, but so far away you still can't see them with the, unaided with the naked eye. So that's exciting to be involved in projects that run the gamut of those extremes. In terms of people, it's just fascinating to be involved and work with multiple disciplines here at Langley, from engineers to other scientists to even patent lawyers, and it's just amazing to see how that all works together for a common goal. Also, there are a variety of educational levels that come through NASA. I've had the opportunity to work with and mentor high school students, work with undergraduate students, graduate students, and it's great to have that freshness of ideas and fresh faces to come through as you work on projects. And the collaborative aspect between industry, academia, and government also are just amazing here. The possibilities facet is also amazing here, where here at Langley we've just had opportunities I've had personal opportunities to grow personally and professionally, and these opportunities allow me to impact the next generation of vehicles, materials, and people. The topics I've learned in school applied to my job are all of my science, math, and any kind of engineering related type material science classes. I've used all of those in the design and execution of experiments, but also the English classes, creative writing, and art classes, which I also have a passion for art. They also have helped enable me through having an understanding of the creative and abstract things and applying that understanding to new things. But to summarize, I think the three lessons that apply the most would be to think critically and creatively, to understand the basics. You will use the basics, contrary to popular belief, and those basics help understand more advanced problems and projects. And finally, to have the determination and the discipline to continue to learn new things.